Kimberly Sorrell. She's the Director of Information Management at Southern Company, and she's going to talk to us about data and analytics, predicting equipment health for key plant, for plant equipment. Kim is the Director of Information Management Office at Southern Company. She's responsible for strategy and execution for data, data analytics, big data, content management, and AI. She's very passionate about data and enjoys doing machine learning in her spare time. Because of course, everyone does machine learning in their spare time, Kim. So I actually first met Kim when we did a LinkedIn Live session a couple of weeks back. We talked about results-driven data literacy with Matt Cowell from QuantHub. And I'm really, really excited to have her back on our live show here today. So Kim, without further ado, welcome to the DATAcated Conference.
Awesome. Thank you so much for having me. I'm excited to be here today.
Absolutely. Thank you so much for being here. I'm going to hop off the stage and I'll get your presentation going for you.
Okay. Thank you very much. So welcome, everybody. I've had an opportunity to be backstage for the last couple of sessions. So I'm really excited, a little scared to follow those up, but very excited about data and obviously data in the energy industry working for Southern Company. One thing that, and I did speak about data literacy a couple of weeks ago, and we have instituted a data literacy program here at Southern Company. I almost talked about that today. I'll probably trickle some things in as I talk about a very specific use case that we worked on. I know one of the things that was discussed in the last presentation was just the plethora of data. Also the culture. You couldn't see me, but I was shaking my head yes and agreeing with everything that was said about culture. So as we try to move toward more digitization and utilizing data for what I'll call the common good for Southern Company, there have been a lot of conversations about, a lot of people are working on various things for conditional type maintenance and stuff using sensor equipment or sensor data rather. And so something we had an opportunity to do with one of our plants and probably kicked off around, time flies when you're having fun, sometime in 2019-ish. And so this has actually been in place for a little while. So we actually have some lessons learned and so forth. And so without further ado, I just have a few slides here to really talk about the process of what we did with the data, what we did with the analytics, some of the findings that we had, and then a couple of dashboard examples of what we came up with. So as we started down this road, we talked about some of our imperatives. And the big question was, how can we leverage data, whether it be from sensors, from locations, from work orders, from national instruments, so forth and so on, to move toward more of a predictive maintenance model. We've been in this preventative maintenance kind of operational model for some time where, maybe, and I'm no engineer, guys, but maybe you go tighten a bolt or, something like that. I'm making it sound simpler than it is. I know it's not. Every 6 months or what have you. And so you would have periods of time that some of the pieces of equipment may actually go down, or sometimes, these plants are huge. The preventative maintenance is very expensive. You have to bring in lots of big equipment and special contractors and stuff like that whenever you're doing things like taking out a boiler water circ pump, for example. Which leads me to my next question here is, what piece of equipment do I select? So we sat around a table and talked about different data and what we have available and so forth and so on. I think one of the things that was very helpful is that with any of these projects, and we've been able to do a few successful projects throughout the organization, really we divided into a few phases. And that first phase is going in and looking at the data. What is available Are there processes that need to change? What does the quality look like? And so I know that's very, very germane to what each of us on this call and then this conference are dealing with day to day. And is the objective one that can be achieved? We have had some consulting engagements where we've had to say, we don't have this, this, and this. I think we need to move, kind of move the needle a little bit in a slightly different way. So you have to be willing to what we call, and I'm sure I know we didn't coin the phrase, but fail forward fast, is be able to really look at our results and as a group make decisions from those as to whether to proceed down the current path or not. And then what other information can be gleaned from this process? So you have we had actually a really big aha from one of the sorry, I have dogs and stuff barking in the background, so I apologize for that. But anyway, as far as something else that can be gleaned from the process, for example, we were able to really figure out which vendors were doing a better job, because there were some vendors that we would send things out to do what was called a motor rewind. And then you could see that there was a half-life after some and maybe like a 3/4 life after others. So it really helped us hone in on, are there any type of training opportunities, or are there just some vendors that are just doing a better job? So we selected a boiler water circ pump. We divided it into 3 phases. And the initial phase was just really talking, figuring out what data is available. And, one of the things that is probably going to be very, very, it's going to hit home with a lot of people here, is that we don't let things fail. And I'm not suggesting that we do. But because there aren't failures, it's very difficult to find a failure proxy. So a lot of people say, I want you to predict failures. So we kind of went from predicting, or kind of going from down the path of predicting failures to, hey, can we predict the health of the equipment? So we started looking at, and initially, since this was one of the first forays down this path, we really did a lot of education with users. We did a lot of education for the people that were on these projects, as far as, plant operations and stuff. But I think the real synergy there was that we did initially work on outputting a statistical model that was explainable. So we hear a lot about being able to explain why the results, the output is what it is. And interestingly enough, oftentimes if people don't have a full understanding of that, there may not be a full trust for the process. So just real quickly, so I'll have time for some questions. After phase 2, we were able to put out a statistical model dashboard. We used some various techniques like principal components analysis and various regression models and stuff. But at the end of the day, we were still able to say these factors, for example, filter changes, various movement of some pumps, I think there was a specific unit that was not operating as well as others, which kind of led us to some of the half-life data. But at the end of the day, what we came up with is that there are 4 units, and then within each unit there are 4 pumps. We were able to, so that's why you see the ABCD. But we were able to do kind of a red light or traffic light type of dashboard. So we call it a health risk dashboard. And as folks see, if you see something turning red, then it has a much higher propensity to fail than if it were green. And, we worked with the business to figure out what those propensity levels were. So we've actually been able to successfully predict a couple of failures now. The next thing we did is we moved into the AI model. And within the AI model, we tried a lot of different stuff, various deep learning. For this specific type of data, we wound up settling on a random forest XGBoost paradigm. And I think I had that here. Just kind of gives you some ideas on the tuning. But of course, once we get to that point, we made the model better, but now we can, it's no longer explainable. That we actually are running the two side by side, just to do comparisons and see what type of information that we can glean from the various types of models. At a high level, it's been working pretty well, and we are looking at other pieces of equipment to move this toward. So, any questions?
All right, thank you so much for that, Kimberly. I'm just going to remove the screen. All right, here we are. Yes, we have plenty of questions. Before we get into questioning, Kim, a lot of people want to meet your dog. So if you can let the doggy in.
Let's see. You saw me I'm sorry about that. Grab the door, and I think he has skedaddled now. So.
Oh, okay. Well, maybe next time.
He is a gorgeous French bulldog who was.
Oh, there he is.
Okay, who was chasing this little guy. This is my kitty cat.
Perfect. Now we have pets at the DATAcated conference. I love it.
Yes.
Okay, let's take a few questions. So Raymond here is asking a question, and he's saying, did you look at all the data you have at first, or do you look at a business outcome that you need and then look at the data that will support it?
That's a very good question. What comes first, the chicken or the egg, right? It's typically you want to go into it with an understanding of what you're attempting to do.
Yeah.
But we were all kind of sitting around the table and really didn't even know what was available. So this was kind of that first foray into what is available for plant data, what makes sense. Some of the things we've even talked about doing is we use Maximo for a lot of work order management, and across all the plants, there's not necessarily common nomenclature. So we've actually been floating, making, some of these models better and stuff like that by doing some NLP on that type of data to create a more varied and rich data set.
Okay.
Yeah.
Thank you. Yep. The next question here comes from Kurt. He's asking, how will AI be used to enhance the energy industry's overall security from remote-based attacks?
Ooh, that's a good question. I bet you heard about a certain pipeline recently. It's interesting. I'm not a security expert by any stretch of the imagination. I actually just took probably a year or so ago, a cyber physical security class with someone at Georgia Tech, Dr. Raim Baya. It's interesting. On NPR had him maybe do 20 minutes of discussion on that very topic. So I'm going to actually suggest that you go find that and speak with him, or see that. But I will tell you that there are a lot of conversations about security.
Yeah.
There's very tight physical security at our plants, and also non-physical security. But they're definitely even looking toward doing data centers that are more secured and so forth. But definitely something that's a topic right now.
Yeah, absolutely. There's several comments coming in around security, so it's definitely a hot topic. Juan Pablo says, Kimberly's the best. I agree. Great presentation and personality, and the cat cameo. So thank you, Juan. Awesome. Well, Kimberly, it seems like this is all the time we have for today. Unfortunately, we do have so many more questions that came in. If you've got the time to jump in on LinkedIn and answer a couple of those, that would be much appreciated by the audience.
Will do.
Awesome.
Will do. Thank you. And Simon says bye.
Okay, bye.